Hello, sir. Hello, everyone. Good evening. So, the title of my project is Prediction and Analysis of Lung Infections Using Deep Learning, a comparative study of InceptionResNet and VGG models. So, it is basically classification of various lung infections using two major deep learning models. They are InceptionResNet V2 and VGG19. The initial proposal of my project is prediction and analysis of post COVID-19 lung infections using Ensemble and CNN. The reason I didn't prefer to continue with Ensemble CNN is the dataset that needs to be done. It's very huge. So this is the dataset. There are over 1,000 files, and each file is of the size 100 MB. So I don't have that much computing power to process all this data. So instead, I choose to proceed with Inception ResNet and as well as BGG. So for this particular project, I am using dataset provided by NIH. It is publicly available dataset. So this dataset has over 100,000 images, and they're from more than 30,000 patients. So this is the link to the dataset, and yeah, this is the dataset. So it has around 112,000 images. So yeah, and using with this code we can download all of the images directly from the link. And we also have a CSV file, which is this one. It has all the data entry for around 112,000 images. It has all the labels and different diseases and everything regarding that. It is a huge data set to work on. So this is the abstract. In this study, we present a comparative analysis between two deep learning models, VGG19 and InceptionResNet V2, for the classification and prediction of lung infections from chest X-ray images sourced from the NIH dataset. So as I already told you, the dataset contains more than 100,000 images from 30,000 patients. The VGG19 model, known for its deep architecture and simplicity, is compared against the InceptionResNet V2 model, which combines the Inception and ResNet architectures to achieve state-of-the-art performance on various computer vision tasks. Both models are fine-tuned using transfer learning techniques on the given dataset. Through rigorous experimentation and analysis, we assess the classification accuracy, computational efficiency, and generalization capabilities of both VGG19 and InceptionResNet V2 architectures. Our findings provide valuable insights into the suitability of VGG19 and Inception ResNet V2 architectures for lung infection classification tasks. Furthermore, this study contributes to the ongoing efforts in leveraging deep learning techniques for accurate diagnosis and management of pulmonary diseases based on chest X-ray imaging. So this is our title justification. The proposed model predicts and analyzes the lung infections that may occur to the patients. So these are the objectives of the project that I choose to compare the performance of two models and find the model which is best accurate and which has more accuracy. So this is the scope of our project. Healthcare professionals who want to identify the lung infections from X-ray images, or the health organization that takes necessary action on the basis of analysis, or the patients who have access to the chest X-ray scans. So these are a few basic concepts and the description. Uh, One of the model that I'm using is InceptionResNet V2, and this is that one, and this is the VGG19 architecture. So the modules in the project are data collection, data pre-processing, data visualization, model building, training, evaluation, and lastly the analysis of InceptionResNet V2 and VGG19. So again, in the InceptionResNet V2, the modules that I'm going to perform is this one. It's just importing libraries, loading the data, data pre-processing, data visualization, and model building training, and model performance visualization. In the same way, the modules in the VGG19, data pre-processing, data resampling, data visualization, model building training, and validation, and finally the output. So this is the data collection, and here's the data collection link. I'm also attaching this PPT to the blackboard. So there are totally 15 classes, 14 diseases, and one for no findings. That means that particular X-ray chest image does not have any kind of disease, and the 14 diseases are these one. So we can also see the images. There are total 100,000 images. Yeah, these are all the images, and it is a sample one. And thank you. So as of the project status, I have completed the data pre-processing and also started working on the training the models. It takes quite a bit of time because it's 42 GB, 45 GB of data to train. And in the same way as well for the VGG19, the pre-processing is done and I'm working on the other things. I'm showing this IPNB on Google Colab so that it is visually pleasant to understand, because each section has its implementation and its output, but it is done on other platform. Thank you so much for your time. Thank you.